Okay, so the topic of my presentation is analysis of broadband usage in urban, suburban, and rural areas. So basically, the agenda is it's pretty much the same as all of you, but it's kind of split into two parts because I couldn't decide which would be the most appropriate way to approach this kind of problem. So I used two different data sets, and so my project is divided into two parts. And once I'm done walking through both the parts, I'll talk about my conclusions. So the problem statement mainly is on the demand side of broadband, and but we already know that the access gap is pretty apparent in the United States. There are rural areas which, because they are low density markets, telecom providers don't want to provide high speed internet there, and because of that, a huge percentage of the United States population does not use does not use internet at broadband speeds. And some of the past studies have kind of blamed that, underserved areas or unserved areas are places where there's low income and there's low digital literacy. But it's not just that. There could also be a lack of demand because of the exceeding dependency on smartphones, or people just don't want to pay extra money monthly apart from what they're already paying for their cell phone bills. So uh, so yeah, this is what I'm really trying to analyze in this project, like what can explain the usage patterns of consumers. So on the right, the graph that you see is kind of a motivation thing and not used for analysis. I joined data from the USDA, which classifies each zip code as urban, rural, and suburban, and also combined the Microsoft data for each zip code's broadband usage. And I clearly saw a pattern that in the rural areas, the usage is well below and much less than urban areas. So it's worth exploring as to what is really causing this difference in usage. So the first part of this project is to kind of uh, explore if usage is dependent on the availability. I mean, plainly, if an area has higher availability, does that mean that that the households in that area would be using internet at broadband speeds? It might seem intuitive, but it's possible that some customers just don't adopt it. So yeah, the variables in this data set that we are going to look into are, first of all, the dependent variable is broadband usage, which is just the percentage of households in the county which are using internet at broadband speeds. And the independent variable is the one provided by FCC's data, which is broadband availability, what percentage of households in the county have access to broadband. So taking a quick glance at what the variables look like. So our dependent variable, broadband usage, slightly had a like pretty apparent a positive skew, which was pretty easily corrected using a square root transform. However, the broadband availability variable, we see this big negative skew right here, which my only option to correct it was a square transform. So this model that we will be fitting will be using the square of broadband availability and the square root of broadband usage. So let's take a look at what the shape looks like. So the coefficient that was calculated for broadband availability is 0.51, which if we factor in the square root and square transformation, it means that if there's a county with 100% broadband availability, only 25% of that population would be using internet. However, when we look at the intercept, it makes less sense because it says it means that at no availability, the population in that county would still be 10% of that population of that county would still be using internet, which is kind of weird. And if we look at the fit of the model in this graph, you can see there is an increased, the data points which are towards 100% broadband availability are not very reliable. And that is why, and that is also pretty evident from the jackknife plot for this model, where we see that there is an increase in residual variance as we go, as we go as the fitted variables increase in value, the residual variance is increasing. And even in the QQ plot, we see that uh, that there are some outliers at the extreme upper quantiles. And so this is where I paused and thought that maybe this is not the best way to figure out if what affects usage, because availability is not definitely not a sufficient predictor. And so I did not go ahead and do any k-fold cross validation and look into more like metrics like RMSE or something. But I thought that maybe this this question can be answered through more granular data, such as individuals survey, which I found online on Pew Research website. So there was this survey data which they had uploaded. The survey was done back in the year 2019, and it collects a host of variables which are not very relevant to the study. But I picked 9 of those, and we're going to be testing that on 1,500 responses almost. So the dependent variable in this particular regression is frequent user, which is a logical or a yes/no thing. So this is going to be a logistic regression. And some of our dependent variables are age, income, education, whether they use Facebook or not. It's a yes/no thing. And YouTube, which is similar to Facebook. And there are 3 other logical binary variables, which are whether they have a broadband subscription at home. No means they might have a dial-up service or a slower service. Yes means they have high-speed service. And whether they own a desktop computer or not. And another factor variable that was included as a predictor was community size, which is urban, suburban, or rural. Just a quick note, the income level and education level are chosen as numeric. They're not factor variables because there is a logical sequence to this variable. So a higher income level indicates that that particular individual is wealthier, and a higher education level indicates that that individual has attained more higher level of education. So in the data set that we got, the usage frequency was kind of distributed in this way, that they had divided it into almost constantly using it several times or several times a week, which is not very helpful when you're trying to do an analysis. I mean, in logistic regression, it's best to have just 2 classifications rather than so many. So I converted the users who are almost constantly using internet and using it several times a day as frequent users, and all of the rest who used once a day or fewer times a week are classified as no, they're not frequent users, and all the don't know and refused are classified as not as just missing data. So now let's look at what our predictor variables look like. So we have a rather higher representation from suburban population, which is all right, I guess. And we also do like a bivariate analysis of what kind of representation do each of these community have, as like how many frequent users are there from urban areas and how many are there from rural areas. And we can see that urban and suburban areas actually do have higher number of frequent users. And going to the income distribution, I mean, I'm not really talking about any of the distribution shapes because this is a logistic regression, and so normality is not really a precondition or part of the assumptions. So I did not attempt to correct any of these distributions, but I did explore how they feature for frequent and non-frequent users. So we do see that non-frequent users have a higher percentage of low income levels, and the frequent users are wealthier. So there's clearly a trend there. And apart from that, when you go to age, you see that younger population is actually a more frequent user of internet, and you see the ones who are non-frequent are comprised mostly of elderly. And also the excuse this error in the heading, but this is the education plot or both of them. And so the education, we can see that the individuals with a lower level of education are also non-frequent users, and higher level of education has more number of frequent users. And just a quick look at our logical variables. So computer ownership, 80% of our respondents do have computers. However, we see that only hardly 60% of our non-frequent users own computers. And so broadband access as well, I mean, it's pretty much, I mean, it's kind of intuitive. Like if they have broadband, maybe they are using it more frequently, but that's not the case because non-frequent users said that only 60% of the non-frequent users are using broadband just as frequently. And so going to the social media usage, because these are some YouTube is a high bandwidth website, Facebook, well, it doesn't require broadband speeds, but it's still, I mean, a good indicator of how much people are using it. It's kind of addictive. So Facebook, you see that non-users are less likely to use Facebook, and frequent users, there is a higher percentage. And similarly for YouTube, we see this same trend. So now it was time, although this is also not a precondition for logistic regression, but it's kind of important so that when you go look at your odds ratio, they come out, reasonable. So but the good news is there was no multicollinearity in any of our variables. I was kind of surprised that the highly educated were not the ones who were also more frequently using it, or higher education did not have a correlation with computer ownership or anything. But hey, this is a random data collected from across the country, so we can't really anticipate those multicollinearities. So this was our initial model. Dr. Canfield would frown on this, but I could not help but put all the variables I had into it first, because I picked 9 out of 74. That was quite a lot of shortlisting. But I noticed that this was not a very good fit. We see from the coefficient estimates that actually the area class is not really a helpful estimate here. And it makes sense because we can't say that if
Ankit, you've reached the allotted time, but I'm gonna give you 1 more minute to wrap up.
Okay, so we got rid of the area class. We did 2 models, one which had the age along with all the other variables, which proved to have a better fit, and it also gave better odd ratio estimates. And model 2, which was without the age, we see there's more it's more overlap between the ones and the zeros in this model. So not really sure. So we'll just quickly look at these numbers to estimate that which one is a better fit. And so model 1, better log likelihood, better deviance, and better AIC value. So definitely that's my pick, although it does have a lower predictive accuracy, but that's just by 1%. So I didn't mind it so much. And the Pearson residuals look very similar for both of them. It's just that for both models, they are closer to 1 at the extreme levels at 1, but at the other negative kind of residuals had a very bad shape. So they have, there are some outliers at the other extreme at 0.
Okay, I'm going to cut you off.
Okay.
So open the floor to questions.